So here's an example of, you have a species here. I don't know yet if it's an acid or a base. And we would like to see if any of these two rules right here or patterns apply to it. So you can tell right away that there's a negative charge. Now, again, if you have a negative charge, then that indicates that you have a base. Which has, again, negative means it has enough protons. Now, what you need to do next is, if it's a base, you need to actually write its conjugate acid and determine its pK after that. So the conjugate acid of this, and let me show you how to do that. Again, this may be really you, in a sense, you are expected to know how to draw conjugate acids and bases from the Gen Chem, and you can actually use that here. But the idea is that anytime you have a base and you want to draw its conjugate acid, it means what you need to do is you have to add H plus. So if we add H plus, it's going to be what? CH3, CH3, right? We're adding one more H. Now, it's going to be neutral because there's a positive charge on the plus right here. There's a positive charge on H. So again, here it is. Negative plus H plus. And of course, this gives us the CH3, CH3. So if I were to draw the conjugate base of this, then I would remove a proton. And again, if it's neutral, it means it leaves behind it a negative charge. But let's actually look up the pKa. So if we go to the chart and look up the pKa of this, it would be right here. It's an alkane. All it is carbons and hydrogens. So this is close to 60. It's close to 60. It's an alkene, what we call an alkene. So let's actually go back to lecture here. So the pK from pKa chart, pKa is almost 60. So what does that tell us about this? Is this a weak acid? Is it what is it? So again, if we go back and look here, anything almost close to 50 or above 50, these are what? Extremely weak acids. So this is pretty much the weakest acid on the chart. I'll put this in red so you can actually see it. So what does that mean? That means that if we have a weak acid, then we must have what? A strong base. So therefore, CH3CH2 minus is an extremely strong base. So this is how you actually determine whether, again, is it weakly acidic, strongly acidic, and then of course determine whether the conjugate base is strong or weak. So again, weak acids have strong bases, and strong acids have weak bases. So keep that in mind. So another important skill that we want to learn in this is actually the idea of determining where the equilibrium shifts. So you will, for now, you're getting these, but you will get to a point where you need to actually draw the products. So let's continue. In a proton transfer reaction, the stronger acid reacts with a stronger base to form the weaker acid and weaker base. So what is happening here? So equilibrium always favors the weaker acid and base. So the weaker acid and base, in a sense, I'll tell you from now, these are actually the more stable ones. They're much more stable. Very well. So let's actually look at how we would do this. First of all, the number one thing you need to do is determine what's the acid, what's the base. So we look around and we see that this H was donated, it's gone, left behind a negative charge. This N took that H and it became NH4. So right away, this is your acid. And once again, draw its pair will be the conjugate base. And of course, this must be the base. And this must be the conjugate acid. So once again, they go together. Use a different color here. Right here. Very well. So the next thing you want to do is you actually want to find the pKa's. So like I said, we will get to a point where you will actually do it without the pKa's, because the pKa's cannot tell us everything about the equilibrium. So you're going to go and find the pKa of the acids. Go and find the pKa of the acid. So here is this acid. So we want to go and find the pKa of this acid. And we want to find the pKa of that acid. So keep that in mind. We can go and find it on the chart here. So let's go. So we're looking here. Keep looking, we keep looking. Here it is. It's about 4.8 for the carboxylic acid. And for the ammonium, ion is about 9.4, 9.4, 9.4. So this was 4.8. And this was a 9.4. Now, once again, the lower the pKa, the stronger the acid. But we want to shift toward the weaker acid. We want to shift toward the weaker acid. So the shift then is toward this side. It's going to shift. So we say the equilibrium shifts to the right. And again, simply because this is the weaker acid. So 9.4 is higher than 4.8, which means that this is the weaker acid. So I know it's the opposites. It's inversely proportional. We can think of it that way. And this is the stronger acid. So we always shift toward the weaker acid. Okay, up to this point, pretty much really Gen Chem. Before you go on to the next videos, This is what's next is the most important portion of this whole lecture. So please come back, ready to pay attention, take good notes, and then, of course, practice.